Okay, this is probably close enough to 2:30. Let me tell you a little bit about the course. Now, I have to be a little bit careful here because obviously I don't want to tell you the answers to things that are on the survey. But the purpose of the course is to teach you to build embedded systems. I can't tell you what embedded systems are right now, but I'll tell you that embedded systems are an extremely important part of the computer industry. And yet they're a part of the computer industry that many people do not realize exists. Now, if you look at the number of microprocessors sold, the microprocessors that are commonly used in embedded systems, like, for example, the 8051 and other processors like that, far outnumber the number of Pentiums and Athlons and so on by many, many times. Many of them are, the embedded ones are old machines, but they still are alive, very alive. Still a very important part of the market, and will continue to be for reasons that we'll understand during the process of the course. There are a certain number of people in the industry who believe that programming of desktops, programming of databases, and so on, things like that, are really going to go away in 5 years or 10 years because fourth level languages and fifth level languages and so on will make that kind of programming obsolete. But there's no danger that embedded programming will go away. And you'll come to understand why also in the course. The survey you're doing today probably gives you some idea of what the topics of the course are going to be. Now, I don't know, obviously, yet, until I've looked at them, how you're finding that survey. But I will tell you that by the end of this term, you'll know every answer there. And you'll know a lot more than that as well. One of the things about embedded design is that it involves a very large number of different techniques and technologies. Okay, it's not simply programming. Okay, I've listed some of that here. Okay, the digital analog circuitry. Okay, you don't have to necessarily be able to design it, but you have to be able to understand it. Okay, physical manufacturing techniques. You've got to understand what they are. You don't have to be able to do them. Right? It's like building a house. You don't have to know how to lay bricks, but you have to know what the process is like. Okay. And then programming, but programming of a very unusual type, because it's programming that is not so much that the programs themselves are complicated. Frequently, they're extremely trivial programs. But the important things become the timing, how fast it works, the memory that it uses, other kinds of things that relate to cost. So we'll certainly be examining all of those things. Now, I say here that this is not going to be a lab course. We don't have the time or the facilities to actually sit you down with a soldering iron or something like that and have you build stuff. I wish we did. We'll use simulation software. Physical hardware will be something that you'll have a chance to see. And I'll bring things in and so on, depending again on what I find out from reading the surveys and what I find out about what you know at this point. It may be that you have already all had everything I need to say about this, in which case we will immediately begin by working on specific real-world projects. But I suspect that that's not true. I suspect that we will spend some time working through, in some sense, background material of various sorts. So that's what the course is going to be about. Now, the class schedule is written down here somewhere. I can't be really specific about this until I see the surveys. This has been a rather difficult course to prepare for that reason. But the way it looks right now, just for the first few weeks, is, well, first of all, this is the time and the place. Right here, right now, Monday at 1:30. There has been a variety of confusions around that. We were originally told it was going to be, whoops, that's not you, that's it. Not your eyes. We were originally told it was going to be Monday, then we were told it was going to be Monday night, then somebody said Friday night, somebody said Thursday night, somebody said Monday night. We're back to now. So this is the time and the place, unless somebody says something different. As far as the detailed schedule, this is subject to change after I look at the surveys. But what I'm planning right now is that next week we will be discussing digital circuits in some way or other. And I won't know exactly in what way until I see the stuff. The following week we will probably talk about circuit modules, the things that you actually use when you're actually trying to create something. And then it's the 22nd that there is no class. The 22nd, we are going to be attending a conference up in Chiang Mai. So unless you want to come to Chiang Mai, there won't be a class that day. So, next topic here. There will be quizzes. There may be a quiz every week. It'll be a very short quiz. It'll be an easy quiz. Typically, it will be based on the readings for that week. And it will be at the beginning of class. Now, the grading, I don't know if they're going to let me get away with this. It's a bit of an unusual scheme for grading. But basically, after today, and not counting there won't be a final exam. I mean, there won't be a midterm. There will be a final exam. By my count, there will be 14 class meetings. Okay. Whatever is due in each class meeting will count for 4% of your total grade. If it's a quiz, if it's a homework assignment, if it's both, whatever, that will be 4% of the total grade. If I don't assign anything and if there's no quiz, then you get that 4% free.